All right, so section 6, this should be kind of review because we've already been doing this, solving linear equations. And we've already covered our two core rules, right? Do the inverse of what's being done to the variable, and whatever you do to one side of the equation, always do to the other. And remember, you kind of work your PEMDAS backwards in a way as well. So just remember that. Work PEMDAS backwards when you solve equations. So we're going to start with adding and subtracting, and then work with our multiplying and dividing, then work with our exponents, parentheses, so on and so forth. Okay, and there's lots of ways to solve equations like we looked at before, so that's where it gets kind of confusing. So let's just take a look at a couple rules that we have first of all. So we have things called additive inverses. It's basically the opposite of a number, where the sum of a number and its additive inverse equals 0. So if I said 2, what's its additive inverse? Well, -2, because if I add those two together, I get 0. So if I say, what's the additive inverse of -34? Well, its additive inverse is +34. It's just the opposite. They should add up to 0. We also have multiplicative inverses, which they don't go to 0 now, but their products make 1. So for example, if I have the number 3/4, its multiplicative inverse is its reciprocal, which is a fraction flip. So its reciprocal or multiplicative inverse would be 4/3, because if I would multiply these two guys, I would get 1, right? 12 over 12, which is 1. Well, if I have a whole number, if I said, what's the multiplicative inverse of -3? Well, -3 is really, well, I always want to consider it as a fraction. So -3 as a fraction is -3 over 1. So its multiplicative inverse would be 1 over -3. Or, you know, -3 or -1/3, whatever. It doesn't matter where that negative sign, as long as on top or bottom or out front. So multiplicative inverses, get it to a fraction, right? It's reciprocal. All right, so let's just solve a few equations here. So I'm trying to get x by itself. Remember, we do the inverse of what's being done, and we work backwards. So I deal on the side with my variable. I'm on the left side. Where's my adding and subtracting? Well, right here. What's the inverse of adding 20? Subtracting 20. Whatever I do to one side, I do to the other. Just follow those rules. So we'd have 4x equals -36. And the last step, well, we're multiplying. What's the inverse of multiplying by 4? Divide by 4. Whatever you do to one side, do to the other. So x equals -9. So start it off nice and simple. Let's build on that now. Okay, so my variable's up top. But just remember, I have two terms here. So you hardly ever want to do any multiplying and dividing when there's more than one term. So when there's two terms, get all adding and subtracting over to the other side. So in that case, I want to subtract this 12 over. Can I add a 5 yet? No, I can't, because it's in a fraction. So you cannot add the 5. It's in my fraction. I have to get rid of the fraction first. So let's go ahead and subtract my 12. So let's go ahead and subtract my 12. So that's gone. So now I have x minus 5. Do I need those parentheses up there? No, there's no number in front of it to be distributed, anything like that. So I can get rid of those parentheses. Divided by 3 equals 8. Well, now, before I can add 5 over, I have to get rid of the fraction. And since this fraction means division, what's the inverse of dividing by 3? Well, multiplying by 3. Multiplying by 3. And just like we talked about, when you multiply by a number, it's really multiplying by another fraction, like 3 over 1. So these 3's cross-cancel each other, and it's really x minus 5 over 1, which is just x minus 5. That's why you do the inverse, because they cancel. And that equals 8 times 3, which is 24. And then we add our 5 to give us x equals 29. And remember, if you're not sure if you got the answer correct, you can always plug this in for x up here and type it into your calculator. I could take 29 minus 5 and get 24, then divide that by 3 and get 8, and add 8 to 12 and get 20. Right? I can always check with my calculator to make sure my equations are solved correctly. Okay, so over here. So once again, we have two terms. One of them is adding. So anytime it's adding or subtracting, move it over. So get rid of this plus 3 by subtracting 3. You could distribute first, but why not just be consistent? So then you got your 8 times 2x minus 5 equals 40. Well, now since this subtracting is inside the parentheses, this is just considered one term right here when there's parentheses. So I'm down to one term, which means I could deal with multiplying and dividing. So I really could deal with this multiply by 8 and divide by 8 on both sides if I wanted to get rid of that, right? And I could say 2x minus 5 equals 5. Or what was the other thing I could do with this 8? I could distribute it as well. So if I did it that way, I'll bring that one over here. I'd have 16x minus 40 equals 40. So either of these ways would work just fine. And whatever you're more comfortable with, go with it, okay? And then we do the inverse of what's being done, work backwards. So we add 5. So I'd have 2x equals 10 divided by 2, and we got 5. Do I get the same answer over here? Add 40, 16x equals 80, divide by 16. Yeah, x equals 5. Either way will work out, okay? They're just all rules of algebra. You can also check your solutions with the graphing calculator. Okay, this is the nice part. Anytime you're dealing with an x, or you can just replace the variable with x, and you can graph. So it's saying that this graph right here is equal to this graph right here. So if I plug those into my calculator to graph, I just graph each side of the equal sign. So I come in here, I'm going to graph 8 times 2x minus 5 plus 3. So I'm going to go 8 times 2x, remember that variable button, minus 5, parentheses, plus 3. And I can also graph a y equals 43. And I'm going to go ahead and graph. Oh, I don't see the graphs. Boy, what do I have to do? Well, if you go to Zoom, sometimes we have some options. There's something called Zoom Fit, and it's all the way down to number 10. Sometimes that fits both lines. So let's try Zoom Fit and see if it gets them both here. So there's my first equation of a line. There's my second. Good. So how do I find this point? Remember, you can hit your trace button. And where they intersect is going to be your solution for x. So I could trace and kind of go over and make a guess. So it looks like it's about, well, it's when y is 43, right? So here's 44. It looks like about 5, right? Well, there's an actual way to find the point of intersection. I'm going to show you that as well, even though we haven't got into this yet. But you have these calc options for your graphs. So I'm going to hit second calc. And I want to find that point of intersection. So I'm going to hit enter. And it says first curve. Well, basically you just select each graph and then you take a guess. So the quick way to do this is just to hit enter 3 times. Otherwise, first curve, well, I'm on my first equation, so I'm going to hit enter. Second curve, yep, I'm on my second equation. I'm going to hit enter. Then it says take a guess at where the point of intersection is at. So you can move over and take a really good guess. It doesn't matter. I could be way away from it and hit enter. It's still going to be that point of intersection. So when y is 43, x is 5. So I should get a solution of 5, which we just did that one, right? Isn't that what we got? X equals 5? Perfect. Okay. So let's use our calculator here first before we solve. Let's check it first. So what I'm going to do is I'm going to graph this left side. So y1, my first equation is going to be 5 times x plus 7 minus 3 over 8. And then my second equation is going to be y equals 14. So if I type that into my calculator, we'll make sure that this is all in the numerator. So I have to put this whole thing in parentheses. So I have to say, if I want all the stuff on top, I got to put it in parentheses. So I'm going to put a left parenthesis right here. I might draw that in so we see it. Left parenthesis, and I'll end it with a right parenthesis there. I don't need one with the 8 because it's just one term. It's just an 8. So I'm going to go left parenthesis 5 times x plus 7, right parenthesis minus 3. End your parenthesis for your numerator. Now the denominator we have to divide, right? That's a fraction bar. Divide by 8. There's that graph. And then y2 is 14. And let's go ahead and graph those two guys. Let's see if it fits. Ooh, yikes, that's really hard to see. Let's try zoom fitting again. So that was down to number 10. So if I go zoom fit, yeah, it looks much better, doesn't it? There's my first graph, there's my second graph. I don't quite see it. So it looks like I need to make my x max. I need to go further in my x direction. So I'm going to go to my window. and I'm going to change my x max. Instead of going to 10, I might jump it to like 50 just to make sure I get it in there. Instead of counting by ones, let's count by 5s or 10s. I'm going to go 10s. All right, graph again. There's my first graph. There's my second. So it's way up here. So remember, you got this little calc function right here. So second, calc, I want the point of intersection. And I can just hit enter 3 times. It's just going to find it every time for you. There we go. So x equals 16. All right, so now let's actually solve this bad boy. So if I take a look right away, can I add this 3 over? No, I can't. It's inside the fraction, remember? So I got to get rid of that fraction first. So it's nice. We're down to one term, right, because there's no plus or minus over here with another term. So I can start dealing with my multiplying and dividing. So the inverse of dividing by 8 is multiplying by 8. Whatever I do to one side, I do to the other. So those cancel, and I'm left with 5 times x plus 7 minus 3 equals 112. And then we got 2 terms, right? 1 term, 2 terms. So deal with your adding and subtracting. So plus 3 plus 3. I got 5 times x plus 7 equals 115. I could divide by 5, but a lot of you like to distribute, so I'm going to go ahead and do that. So 5x plus 35 equals 115. And now we can subtract 35 over. And we got 5x equals 80 and divide by 5. And what do you know? We got 16, just what our calculator gave us. Awesome. So you have a way to check your solution now, don't you? By using those graphs on the calculator. All right. So let's get some more practice with our equation.